All right, here's the homework sheet for rational functions, and you can work it through with me if you like. Some of it did it in class and some did not. All right, for number one, for step one, to factor what you can. There's nothing factorable. So the domain comes from the bottom. X cannot equal -1. We're not going to worry about the range. The x-intercept comes from the top. So you add 3 and divide by 2. That's 1.5. The y-intercept, you plug in 0, and you get -3 over 1. The vertical asymptote comes from the bottom. Make sure you write it as a line. X equals -1. It's the same power on the top and bottom, so I go power over power for the horizontal. So 2 divided by 1, that gives me 2. There is no holes here. So when I start my graph, I'm going to start at 1.5. Then I'm going to go to -3. I'm going to put down the asymptote at x equals -1. Then I have a horizontal at 2. And now I can start my graph. So I have 2 points I'm going to connect. I know the end behavior is going to be the horizontal asymptote, and at the vertical it's either going to go to positive or negative infinity. In this case it's below the horizontal, so it's going to go to negative infinity. Now I need a curve on the left as well. What I do know is that this is an odd vertical asymptote. The exponent you don't see is 1 on the bottom. That means on one end it goes up forever and one end it goes down. So if this goes down forever, then on this side it must go up forever. And I also know the end behavior is going to be the horizontal asymptote. But I need a point to plug in. So I'm going to take a number less than -1 and I'm going to plug it in just to see what the value is. So 2 times -3, take away 3, and then -3 plus 1. So that's -9, -2, that's 4.5. So I'm going to go to -3 and 4.5, and now I have a point to curve through, and now the graph is done. You could have also picked -2, -4. As long as it's on your graph, you can plot it and then curve through it. Number 2, and again always, you try first and then press pause, then see the video. So the first thing I notice is I factor a 3 out. That's x plus 2 over x. There's nothing that's removable, so there's no holes. The domain x can't equal 0 from the bottom. I'm not worrying about the range. The x-intercept is from the numerator. That's -2 and it's odd. The y-intercept, you put in 0 and you're left with 6. The vertical asymptote's from the bottom. It's 0 and it's odd. The horizontal, power over power. 3 divided by 1 gives you 3. So when I go in my graph, I'm going to find -2. I'm also going to find 6. I'm going to have my vertical asymptote. Oh, what did I do? When I plug in 0 for the y-intercept, I'm being silly here, there's no y-intercept. Because when you plug in 0, you end up with 6 divided by 0. And is 6 divided by 0 6? No. So that's silly. So it's just no because there is an asymptote over the axis. So there's no y-intercept. Just the x right there. All right. But we do have a horizontal one, and that is at 3. So right now I only have 1 point to curve through. So I'm going to do that. So the 1 point I have, I know it's going to curve up to the left, and there's the end behavior, and curve down to negative infinity at the vertical asymptote. I need a point on the right side. So I'm going to pick a number that's bigger than 0. So I'm going to pick 2 and think that might be on my graph. So if I plug in 2, I get 6 plus 6, 12. I get 6. So at 2, it's 1, 2, 3, 4, 5, 6. Now I have a point to curve through. So I know one end goes down, one end goes up, because it's odd. I have a point to curve through, and I know the end behavior is the horizontal asymptote. All right, number 3. Step 1 is to factor it. So that's -6 and 2. And what I notice right away is that there's a factor that removes. So before I remove it, I know that x can't be -2. And then I recognize that -2 gives me a hole because it's removable. So when I plug -2 in, I then can get the x value of that hole, which is at -8. So we have -2 and -8, and that's a hole. Now, what's left over is just x subtract 6. And if you like, there's a 1 on the bottom. So I'm not worried about the range. The x-intercept then is 6, and it's odd. So the exponent you don't see is odd. The y-intercept Well, when I plug in 0, I get negative 6. There's a 1 on the bottom, so there's no vertical asymptote. Nothing makes the bottom 0, because it'll always be 1. And the top is more powerful than the bottom, so that means there's no horizontal asymptote. So I have a point at negative 2, or a hole at negative 2 and negative 8, which is right at the bottom. I also have intercept at negative 6 and at positive 6. This is going to make a line that has a hole in it. So if I graph x subtract 6, you'd start at negative 6 and go up 1 over 1. The only difference with this line is that there's a hole in it. Number 4, step 1 is to factor it. So the numerator is x plus 3. The bottom is x plus 2, x plus 3. So right away I can tell x cannot be negative 2 or negative 3. I see something removable, so what's removable creates a hole, and what's left over is x over x plus 2. So to find the y value of the hole, I plug in negative 3, and I'm left with negative 3 divided by negative 1, which is positive 3. So we have a hole at negative 3 and positive 3. The numerator, the 0 is 0 and it's odd. The denominator, the 0 is negative 2 and again it's odd. The y-intercept, when I plug in 0, gives me the answer 0. And the powers are equivalent, so I just divide x squared over x squared, or 1 divided by 1, and that gives me 1. So I have an intercept at 0. I have a hole at negative 3 and 3. And then I have a asymptote. So at negative 2 and 1 at 1. So with this point, I know the end behavior is going to the asymptote, and it's below. So I see the curve that's going to happen there. With this one, I see the same thing. I see the hole above, so I know that because it's an odd vertical asymptote, that one end goes up and one end goes up, down and one goes up. And I know it's going to curve, and the end behavior is the horizontal asymptote. Turn the page. First step is to factor. That's a difference of squares, and in the denominator factor out an x. Notice the denominator 2, there's no 0, but in the bottom, negative 4 makes it 0. The x-intercepts, well, I got to then remove the x plus 4, so there's a hole at negative 4. When I plug in negative 4, I get negative 4 take away 4 divided by 2, so that's negative 4. So at negative 4, I have a hole. X-intercepts. What's left in the numerator after I removed is x subtract 4 over 2. So for x subtract 4, I have an x-intercept at positive 4. I have a y-intercept when I plug in 0. Negative 4 divided by 2 is negative 2. There's no vertical asymptote because we have a constant in the bottom. And we have no horizontal because the top is more powerful. So let's put down 4. Let's put down negative 2. Let's put down the hole, which is at negative 4, negative 4. And then, again, it's going to be a line with a hole in it. Number 6, we're going to factor first. So I'm going to factor out a 2. I'm going to factor out a 2. So I'm dividing to see what's left over. And then I'm going to continue to factor. So in the numerator, the two numbers that multiply to negative 20 and add to negative 1 are negative 5 and positive 4. In the denominator, it's going to be negative 5 and negative 2. They add to negative 7 and multiply to 10. So I can see what's going to be removable, 2, but the 2's that remove do not create a hole. But x subtract 5 do. So a constant, that's fine. That just removes without a hole. But this one's going to create a hole. So I know there's a hole at positive 5. And then I need to write down what's left after you do the removing. So what's left after you remove is x plus 4 and x subtract 2. So when I plug in 5, I get 9 over 3, which is 3. So the whole at 5, 3. The domain comes from the very beginning before I start crossing out. It can't be 5 or 2. 5 creates a hole. 2 creates a vertical asymptote. The x-intercept comes from here. So the 0 on top is -4, and it's odd. The y-intercept, plug in 0, and you get 4 divided by -2, which is -2. So find -4, find -2, whoops, -4, 1, 2, 3, 4, -2, there it is. The whole, which is at 5 and 3. We also have a vertical asymptote at 2. And we have a horizontal at 2. I need to write that down. So 2 divided by 2 is 1. Sorry, not 2, but 1. Ignore this little faux pas. But there is a hole right there. So I got all the points I need. So I know this is curving down in the middle, and then the end behavior is the horizontal. I know that if this end is down, the other end is up. And again, it's going to curve through the hole and then follow the horizontal. So you see the end behavior and the behavior at the vertical asymptotes, and a hole or a point we can use to curve through, and it's done. All right, 2 left. Number 7. Step 1 is to factor. So that's 2x plus 1. If I factor out an x squared, that's x plus 1. So x cannot be 0 or -1. That would make the bottom 0. X plus 1 removes, and you're left with 2 over x squared. So at -1 there's a hole, but at 0 there's a vertical asymptote. Now this vertical asymptote is even because it has an even exponent. When I plug in -1 into what's left over, you get 2 divided by 1, which is 2. Because the bottom is more powerful, it's y equals 0. There is no x-intercept because there's no x's left on top. When I plug in 0 for x, again, it's undefined, and there's an asymptote over there, so there's no intercepts. So now I'm going to graph this. So I have a hole at -1, 2. I have an asymptote over the y-axis and another one over the x-axis. So both axes have asymptotes. So on one side, I understand what's going to happen. So I understand it's going to go up and then curve down. On the other side, it will match it. So the even vertical asymptote makes both sides go in the same direction. I don't have a point. I know the end behavior, but I need a point in there. So I got to pick a point bigger than 0. So 1, 2, or 3. I'm going to pick 1 because I see that if I pick 1, 2 divided by 1 is 2. So at 1 and 2, I have a point I can curve through. All right, one last one left. Number 8. So step 1 is to factor. So the denominator you can factor out in x, and then you can keep factoring it. So when I look and factor out in x, what's left over is x plus 3 and x minus 1. Then when I look, I see x's are removable, and what I'm left with is 4 over x plus 3, x minus 1. All right, so when I look at the denominator, there are 3 numbers x cannot be. 0, and 0 creates a hole, and 3, that's negative, and positive 1. So we have a vertical asymptote at -3 and at 1. There are no x-intercepts because we just have a 4 on top. When I plug in 0, well, 0 creates a hole. Now when I plugged in 0, so when I do the work for 0, 0 plus 3 and 0 take away 1, that's -4/3. I know on the answer key it says positive, but that's a typo. It should say -4/3 for that. We have a horizontal asymptote at 0 because the bottom is more powerful. So we're going to find -3. We're going to find +1. I'm going to find the whole, and the whole is at 0 and negative 4/3, so it's somewhere around here is the whole. And when we have a horizontal at 0. So right now all I know is what's in the middle. I know there's no x-intercept, so it's not going to go up from this hole, so it is going to go down. And I also know that we could plug in numbers to see what's going to happen. So if I plug in negative 1 or negative 2, you can see what answer you get. So if I plug in negative 1, I get 4 over 2 times negative 2, so that's negative 6. So I get negative 2/3. So it actually is going up a little. If I plug in negative 2, I get 4 over 1 and negative 3. That's negative 3. That's negative 1/3. So I can tell pretty confidently that at negative 1, it's a turning point because I see the symmetry that's being created here around it. So you can see it. It's not going to cross over the x-axis because there's no x-intercept. So it only has one direction to go, because at the vertical asymptote, it's either going to go up forever or down forever. Now, for each asymptote, vertical, they're odd. Now, why does that help me? Because one is down and one's above, one is below and one is above. I already know the end behavior. I just need to find a point that's less than negative 3. So I'm going to plug in negative 4. So when I plug in negative 4, I get negative 1 and negative 5. So that's positive 4 over 5. So negative 4 gives me positive 4 over 5, which is darn close to 1. So here's one part of the graph. So at negative 4, I get 4/5. On the other side, I'm going to plug in positive 2, just a number bigger than 1. So if I plug in 2 on the bottom, 2 plus 3 is 5. 2 take away 1 is 1. So it's 5 times 1, which is 5. So I see the symmetry there. So it's 2 and again 4/5, which is darn close to 1. So I have a point to curve through. And you finish the graph. Understand the behavior at the vertical asymptotes and the behavior at the ends. And then understand there are no x-intercepts. So it's what direction it must go. And I did a table of values to fill in some points to help me be as accurate as possible. So again, there's no y-intercept. There's the graph. Awesome job practicing with me, making sure you finish your homework. This is it. Mr. G Math, over and out.